So let's look at everybody, stem and leaf. Are we there? Stem and leaf. So the stem and leaf plot, the stem and leaf plot is a diagrammatic technique for visualizing a data or a data set using a system of separating each data entry into two parts, namely the stem and the leaf. I nearly said praise God. I wanted to say, do you understand? But I nearly said praise God. It won't be out of place because I know that in this region, almost all of us are Christians. You know so? Okay, so we won't waste so much time on this. I'm going to explain everything clearly. Is it clear? So the question starts with answering. The first question is answering the meaning or giving answers to the meaning of what? Stem and leaf. So what is stem and leaf or stem and leaf plot? It is just a diagrammatic technique for visualizing a data set. Now the question is, how do you visualize a data set using this plot called the stem and leaf? We use a system that separates each data entry into what? Two parts, namely the stem and the other one, the leaf. Is it clear? So, the stem is usually a digit or set of digits from each data entry, taken from the left, while the leaf is usually the last value in a data entry, after taking out the stem. Full stop. So everything will make clear sense if we use this example. What example number are we, guys? What example number are we? This example now will be example what? Example 12. Okay. So use a stem and leaf plot to visualize the data below. Please, could you all put your phones on silent? Could you do that quickly? 10, 40, 46, 11, 12, 13, 18, 20, 26, 21, 15, 40, 43, 45, 35, 37, 38, 29, 24, 26, 23, 21, 22, 24, 17, 19, 18, 21, 32, 30, 36, 24, 23, 32, 37, 31, 48, 50, 50, 47, 41, 42. Okay, so how many do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 8 by 5 is 40, right? 8 by 5 is 40. So now, after using this example to explain certain things, I want to use this example to kickstart my class on this particular section, the stem and leaf. After using this example, what follows next will be made very, very clear. Is it clear? Now, I'm going to make several remarks after this. I'm going to make several remarks. So please, if you are finished writing, put your pen down and look at the board. Are we there? So, please look up, everybody. Just put your pen down. Now, if you want to use what we call a stem and leaf, you know we've discussed so many graphical techniques. Out of all the we are going to write it down because it is important. Out of all the techniques used so far, the most preferable technique that helps you visualize data best is this technique. And I'm going to give you the reasons why when we write it down. But let's take this example as testing. See, if I tell you now, use the stem and leaf, it is very easy. Very, very easy. What you will do for me is to draw something like this. You remember what we did in our primary school using singular and plural, present tense and past tense, right? So you just draw a table like that, and you call this one stem, and you call this other part leaf. Is it clear? Now, the next thing you could do is you will look at the data very well because it is very important. You will notice that the smallest value in my data runs from 10 to 50. Have you noticed it? Now, my data runs from 10 to 50. I would now, if you look at it from 10 to 50, I can split 10 into two parts, 20 into two parts, 30 into two parts, 40 into two parts, 50 into two parts. Any number in what? In tens, I can split it into two. Any number in what? 20s, I can split it into two. So what we are going to do, even as you look at numbers that are in tens, numbers from 10 to 14 will be categorized as low. So we have 10 low and 10 high. Any number in tens but greater than 14, greater than 14 we will call high. Lesser than 14, lesser than 15 we will call what? Low. So I'm going to put here 1 low, 1 high. You see that? I will put 2 low, 2 what? High. 3 low, 3 high, 4 low, and what? 4 high. Then 5 low and what? 5 high. I'm going to put my spread under what? The stem. Now, look at it this way. Once you get that done, please just go back to your data. 10 is the first value. I will put, because 10 lies between 10 and what? 14. 10 to 14 is what? Low. 15 to what? 19 is high. Is it clear, everybody? 20 to 24, low. 25 to 29, high. And so on. So I'm going to start with 10. 10 is low. So I'm going to take this one here. The one you are seeing here is this first one. You understand me? You will put, once you take out the stem value, you put the remaining under what? Leaf. So I'm going to put here 0. So when I see 1 and 0, it means it is what? 10. The next one is what? 40. 40 will fall under 4 low. So I'm going to leave the 4 here and put what? 0. I'll mark this one out. Huh? Go to 46. 46 will be categorized under 4 high because it is above 46 is above 44, right? So I'll come to high here and put what? 6. 11 will be 1 here. Is it not so? 12 will be what? 2. 13 will be what? 3. 18 will be what? 1 high. You see it? 20 will be 2 low. 26 will be what? 2 high. 21 will be what? 2 low. 15 will be 1 high. 40 comes under what? 4 low. 43, 4 low. 45, 4 high. 35, 37, 38, then 29, 24, 26, 23 and 21. Right? 22, 24. You see it? Then 17, 1 high. 19 and 18. You see it? 21, 32, 3 low. 36, 24, 23, 24, 23. That is 24 and what? 23, right? 32. 32 is what? 3 low. So I'm going to put here 37, 31, 48, 4 high, 50, 5 low, 47, 4 high, and what? 41, 42. This is a stem and leaf plot. Is it difficult? So it is not. Now, let's now, before we write down, consider the following thing for discussion. Because obviously you can now see that there is no big deal about this stuff. Is it not so? So, very good. Now, there is something we are going to discuss when we get into measures of central tendency, measures of dispersion, and measures of skewness and what we call kurtosis. Please take note. When we get into measures of skewness and kurtosis, you will come to realize something. For measures of skewness and kurtosis, we are describing the distribution. First thing I want to tell you here, please, you see this data here. We call this collection of points or values. We call this, put together, we call this a data set. Is it clear, everybody? So all these values you see here, put together, makes what we call what? A data set. Each of them inside this data set is called a data entry. Is it clear? If you don't want to call them data entries, some textbook or online sources will call them data points. That is why, coming back to the story, I told you the example will set the pace for what we want to do or set the tone. Coming back to the example, you will realize that we had said that the stem and leaf plot is a diagrammatic technique for visualizing what did I say here? A data set. You see it? So when I say we are visualizing a data set, what was I trying to say? To visualize something like this. You see it in this manner. Now, using what? A system of separating each data what? Entry. So by data entry, I was referring to these values inside the data set. Do you understand me now? Now, by separating each data entry into two parts, one part called the what? The stem, and the other part called the what? The leaf. Is it clear? Now, what did we say? We said that the stem is usually a digit or set of what? Digits from each data entry taken from what? The left. Some textbooks or online sources will tell you that when you use stem and leaf, you are using what we call their place values. They are not wrong. So if you go on the internet and you find such a definition, they are saying the same thing. Is it clear? In this example, our values were in tens. They can give you numbers whose values are in what? Hundreds or in thousands. What that definition on the internet or in a textbook will be telling you is still the same thing as this. You take the place values or the first set of digits from what? The left. The last digit is usually categorized under what? Leaf. Now, I believe I can wipe this off, right? Just this one. Oh. Now, please, before you write down, look up everybody, please. Why is stem and leaf very, very important? Stem and leaf is important because out of all the graphical techniques, it does one thing that all the techniques do not do. It preserves the data in the way it came. Let me tell you why. Look at it this way. Let's assume that there was a data on the board and you use that data to get a pie chart. After getting a pie chart, I want to call all the graphical techniques we have used previously. Let's assume that there was a data on the board and we use that data to plot a pie chart. Are you following? I now clean off that data. Let's say nobody wrote that data. I now clean that data that produced that pie chart and tell you, use the pie chart to produce the data the way we got it before. You won't be able to do that. If you move away from a pie chart to a line graph, you cannot do that reversal process. If you move away from a line graph to the histogram, you cannot do that reversal process. Once you clean up the data that produced the histogram, you cannot use that histogram to produce the data exactly the way it was. If you move away from histograms to bar charts, you cannot do the same thing. If you move away from histogram to pictogram, you cannot do it. Frequency curve, you cannot do it. But the only technique, even box plot cannot do it. But the only one that preserves the value, look at this. See, if I clean this off now, what I'm trying to say, everybody, is the advantage stem and leaf has over every plot we have discussed previously. Is somebody following me? Yes, sir. So the first advantage of stem and leaf is that it preserves the data undiluted. It preserves the data in the sense that now I have cleaned up the data, is it not so? If you now ask me what values were in the data that produced this stem and leaf, I will just come over and tell you 10, 11 was there, 12, 13, 18, 15, 17, 19, right? 18, 20, 21. I will move until I get to what? 50. Do you see it? It is the only graph with which you can do what? Reverse the process. Am I understood? So when you hear us use the language that stem and leaf preserves the data, that is what we mean. That is advantage number one. Advantage number two is that stem and leaf, the only graph that does something similar in this manner to the stem and leaf that I want to say is the histogram. If you remember my note on the histogram, I must have told you somewhere in that note, I believe I mentioned it, that the histogram can help you visualize the distribution of the data. That is the normality or the abnormality of the data, right? I must have mentioned that. Now, if you can do this on your notes, Let's assume that you've written this on your notes. If you turn your note upside down, you will be seeing something that looks like the histogram. That is, after plotting a stem and leaf like this, you know you're writing vertically your note, right? Turn your note like this. It will look as if you are plotting. Each of these lines will now look like what? Graphs. So on it, you can put a particular shape like this across the values to show you that, for instance, this one that we have plotted is not normal. These values that we've plotted is showing us that this distribution is what? Is skewed. You will come to know what I mean subsequently, but not now. So the stem and leaf can also help you tell whether a distribution is skewed or not, whether it is normal or not. Number 3, the stem and leaf is an elegant way of presenting what? Data. It is very elegant, just like every other graphical technique for presenting what? Data. So quickly, let's put those advantages down. Of all the techniques for graphically or diagrammatically presenting data, stem and leaf remains best for the following reasons. One, it preserves the original data. Two, it describes the shape of the distribution, whether normal, skewed, whether normal or skewed. 3, it is as elegant as any other technique. 4, it can be used to deduce statistical measures like the mode, median, etc. Okay. Let's look at example 13. After writing this. Is there any question? Yes, what's the question? Yeah. I don't understand, please.
For example, now your data entry and the US number there is 0, and the highest is 5. Can I make my own 1, 0?
Yes, yeah, you can. It depends on the data you have. Like this data, the data I want to put here is of that nature. Okay, use the stem and leaf plot to visualize the data below. So I want to put here 100, I want to put here 105, I want to put here 103, 121, 111, what do you call it? 114, 116, 132, 143, 159, 160, 121, 134, 115, 119, 133, 142, 145, 148, 154, 160, 153, 124, 138, let me put here 106, 102, 127, 143, 149, 158, 154, 121. Let's use this data. Now the question says use a stem and leaf plot to visualize that data. So I'm going to put my solution here. I'm going to put my solution there and then go down. So I'll put here a stem, I'll put here a leaf. Okay? Now for my stem, looking at my data starts from 100 and ends at 160. So I'm going to use 10. I'm going to use 10. My data is now in tens, right? Is in hundreds rather. Is in hundreds. So I'm going to have 10 low, 10 high, 20 low, no, 11 low, 11 high, 12 low, 12 high, 13 low, 13 high, 14 low, 14 high, 15 low, 15. So now I hope everybody followed what I did here. In this case, looking at the data, if you look at the data, my data is in hundreds. You see it? 100, 105, 111, 114. So what I'm doing now, I'm taking the first two digits. I'm grouping using the first two digits. So 10 low is me taking the first two digits out of 100 and then what? 0. So from 100 to 104 will be a low. Do you understand me? From 105 to 109 will be what? A high on that level. Then on this one, 11 low, every value from 111 to 104 will be what? A low. 105 to 109 will be what? A high. So let's start. This will be what? 100, right? This will be what? 10 high. I'll put 5 here. You see it? So if you put them together, what will you have? 105. You see it? Then this one is what? 1 low. Is it not so? I'll put 1 there. This will be what? 1 low too. Is it not so? This will be 1 high. So I'm going to put 6 here. This will be 160, which will come under what? 16 low. You see it? Reading as 160. Then this is 106. 106 will come under what? Yes. Yes. I'm taking the first two digits. Your leaf is the last digit. Do you understand me? Your leaf is the last digit. And the last digit in this case is what? The last digit in this case, for instance, is what? 6. So, how did I get it? No, it should have been under, it should be here. Now, 127. Yes, now. 10 and 0, low. That is from 104, from 100 to 104 is a low. From 105 to 109 is what? A high. From 111 to what? Or even from 110, if there was 110, from 110 to what? 114 is a low. From 115 to 119 is a high. Do you understand me? Then when you now get into 120, 120 to 124 is a low. 125 to 129 is a high. So you take these first two digits and put under stem, and the other two digits you put under what? Under leaf. The remaining digits rather you put under leaf. Now, for the first one, we took the first two digits here, and the remaining one is what? 0. A low. This one, the first two digits, 10, but because 5 is greater than 4, it goes into a high. Then 1 1 now, the first two digits is what? 1 1. But 1, the last digit, is a low. So it comes under here. The next one also is a low because 4 is below 5. Is it not so? So we put it under a low. But 116 should be what? A high. 116, this should be what? A high. Then 160 is this one, a low. Whereas 106 should be what? A high, under 10. Then 127, where would we put 127? You see it. Then 103, where would we put it? Where would we put 121? 132, where would we put it? A low. 143, where would we put it? 14 low. Where would we put 159? 15 high. Where would we put 15 low? The next one, 10 what? Low. This one, 14 low. 14 low. The next one, 16 low. Good. The next one, 12 low. 13 what? 13 low. 14 high and 11 high. Good. 11 high, that is 5, right? Still 11 high. Then 12 low. Another 12 low. Then what else? 14 what? High. That is 9 here, right? Then 13 what? 13 low. That is 3. 14 low. 14 high. 15. Still 14 high, right? 8 here. 15 low. 13 what? 13 high. Oh, so this should be 8. Then 15 what? 15 low. That's 4, yeah? Then 15 what? You see it? Okay. Is there any question? Now, my remarks, I'm going to make several remarks. When we get into measures of central tendency, we will still use these graphical techniques we've discussed. But I'm going to make my remarks then on something called depth. In some textbooks or online sources, they will add, before the stem, they will put what is called what? Depth. I'm going to explain that when the time comes. Is it clear? Good. So let's now go to frequency tables. Let's go to frequency tables. Once you are done with this, let's go to frequency. Now we are done with all the graphical techniques I mentioned, right? Is it not so? So let's go to frequency. I believe I can wipe this off. Let's go to frequency tables. Please, who can tell me why are we discussing frequency tables? Why are we discussing frequency tables? Who can tell me why we are discussing frequency tables now? We are still under organization of what? Data. Is it not so? We are under organization of data. And under organization of data, we say data can be organized graphically or diagrammatically, or if not through those means, through the means of what? Frequency distribution or frequency what? Tables. Now we are done with discussing some of those graphical techniques. We are now under using frequency tables to organize what? Data. So quickly, a frequency table, otherwise called a frequency distribution, is a summary table that organizes organizes a data set into two major columns, namely the data entry column and the frequency column. Full stop. So what we call a frequency table is a summary table, such that when given a data set, you can now categorize the data set into that summary table, putting one set of the table, one column from that table will be for the data entries, and the other column will be for what? Frequencies. Now, a frequency table may be used to represent or summarize, let me better use the language organize, to organize a small volume of data or a large volume of data. For a small volume of data, we often may use a frequency table called an ungrouped frequency table. Ungrouped frequency table. Whereas for a large volume of data, we may resort to using what is called a grouped frequency table. A group frequency. So basically, there are two types of frequency tables. Am I talking to people? One is called what? Group frequency table, and the other one is called what? Ungrouped frequency table. Now, certain circumstances will prompt you to use what? Ungrouped frequency table, especially when the volume of data is what? Is small. Is it clear? But not in all cases, so please take note. But for cases where the volume of data is very large, we will always prefer or recommend you use what? A grouped frequency table. So, based on that, let us start with the ungrouped frequency table. Let's start with ungrouped frequency table. According to Chebyshev, a sample data of size n is regarded as being small if n is less than or equal to 30. Okay? So, however, if n is greater than 30, strictly greater than 30, then the sample data is regarded as being large. As being large. The ungroup frequency table. The ungroup frequency table is usually characterized by a data entry colon denoted by X and a frequency colon denoted by Fi. Full stop. Paragraph. In an ungroup frequency table, frequency means the number of times. Frequency would mean in an ungroup frequency table the number of times a data entry repeats itself or reoccurs. Full stop. Now, please listen, everybody. Now, there is a particular concept we call, or principle we call Chebyshev's rule. Do you understand me? We call it Chebyshev's rule. Now, please listen. Look at this class. In this class, we have so many students here seated. Is it not so? If you remember our discussion previously, we had said that when you obtain data by counting, that data will be called discrete. When you obtain data by measurement, it will be called what? Continuous. Now, if I come into this class and take all your heights, I would have, if there are 102 students in this class right now, I will have 102 heights. Is it not so? Now, I may consider 102 heights as being very large for me to handle for what I want to do. Somebody whispered into my ear that students are performing poorly based on their height. The taller the student, the poorer the performance. The shorter the student, the better the performance. And I now decided to investigate on a certain day to know how true that is. Could there be any correlation between the height of students and their performance in academics? So what I now did was I came into class and I administered a test. I taught my students a particular thing and gave them an example and told everybody to work on that example. Now, after working on the example, I collected all your scores and then told each person, come out and give me your height. So everybody, after collecting their test, everybody came out to give me their respective heights. Now, because of time, the time remaining for me to do the computation to now evaluate whether this is true or false was so small that I could not make my judgment based on 102 heights. Now, if you cannot make your judgment based on 102 heights, because 102 height was coming from everybody in this class under study, we will use N in statistics, capital N, to represent the population size. That 102 will make for what we call the population size. Is it clear? But if you now say 102 is too much for me to handle based on time, but I want to just consider 40 or 30, that 40 you want to consider will be called small n. Do you understand me? Are you listening? The 40 you now decide to select to use because of not having time or any other reason instead of 102 will be called the sample size, while this one will be called the population size. Is it clear? Now, you see this guy, this Russian mathematician, Chebyshev. Chebyshev said that even nobody should think that when something is called a sample, it means it is small. For example, who goes, let me give you a good example. You see, if you think about it critically, you discover that the government is telling a lie. When it comes to population census, who told you that in Nigeria, when they come out, the government comes out to tell us that altogether we are 150 million in this country? Everybody will applaud them and say they are saying the truth. Who told you? How did they count? How did they do the counting? Are we truly 150 million? That is question number one. If you look at it critically from one angle, if you are not a statistician, you will say the government is telling a lie. But is the government telling a lie? In some case, logically, statistically, they are not telling a lie. Now, let's come from the angle of a layman, where you would have to consider that the government is lying. Look at it this way. If the government comes out to tell us there are 150 million persons in this country, it means that they have counted everybody in the northern states. They've counted everybody in the southern states, eastern states, western states, right? And put all the figures together, it gives them 150 million. But the question is, are they correct? Now, if you want to argue the validity of that number or the falsity of that number, come from this angle. The first question I would ask is, the guys in Zambisa, those terrorists there, they were in Nigeria when that counting was done. Who counted them? So, is it that, picture that scenario. They now say, come on, we want to do census in the country. Let's count everybody in the country, including those in Zambisa. So we now went there. Good morning, terrorists. We are all statisticians coming to count you. We are not here for war. We are here for peace. We just want to count and go. Huh? You won't even step close to that place before they release fire. And if you succeed among all those who died after releasing fire, that you finally entered there, you are not coming out. Do you understand me? Question number two. We know fully well that the northern culture or tradition is such that they don't, you rarely, if you go to the north, you may not see a particular allergy having more than 20 wives or 15 wives or 10 wives. They keep all of them in one house. You don't just enter there and count anybody and come out anyhow. They may not even allow you. They will just stay outside and declare the number that we are 60 inside, and that's the number you take. So the question again is, who went into that place to count all the wives of the allergy? So how did you get 150 million? Question number three. We know also that aside, now that the eastern states are tens, you don't just go in anyhow and come out into certain places. Or let's even go into the creeks in Bayelsa. Who went there to count those militants? Because they are part of the 150. Do you understand me? They are part of what? The 150. So what Chebyshev is saying is that statistically, for all these reasons, whether some places are remote, that is being far away from where we want to do the counting, or some places are inaccessible, Chebyshev is saying that most times you may not be able to use the population size. You would have to use what is called a sample size. And when you talk about sample, most people usually think because it's a sample, it must be small. No. Chebyshev is saying that a sample drawn from a population can be large or what? Small. And the question is, when is a sample drawn from a population large? It is when this sample size n is greater than what? 30. If the sample size n is greater than 30, then that sample is a large sample. But if the sample size is less than or equal to 30, it is what? Small. Now, what we are saying is that the ungrouped frequency table is always characterized with two columns: data entry column and what? Frequency column. Is it clear? Please take note of one thing, everybody. When you are dealing with ungrouped frequency table, frequency has a different meaning to when you are using frequency in a group frequency table. So question is, what does frequency mean in an ungrouped frequency table? Frequency in an ungrouped frequency table means that And you are talking about the number of times each data entry repeats itself. Is it clear, everybody? The number of times each data entry repeats itself is called what? Frequency in an ungroup frequency table. Example 14. This class is to end. I said I'm going to use 1 hour for this class. This class ends 3:16. I can see so many of you sleeping behind. You understand me? So, no. I didn't. It's not. I'm not blaming you people. I'm not blaming those sleeping. It's your right to sleep. The only thing is that you are sleeping at the wrong time and in the wrong place. Probably next time when coming to class, I may bring a bed. I'm told in Finland, when you are tired of having a class, you just jump on one bed in the class and sleep. I don't know how true it is, so I'm not the one that said it. I'm only quoting what, but I don't think it's for an adult class. I think it's for children. But I don't know how true anyway. Now, please, so this class ends 3:16. Is it clear, everybody? So you can, what it means, the reason why I'm telling you the time is just in case, see what you wanted to do. You wanted to do something like this now. As soon as I say the class will end 3:16, you now decide to postpone your sleep. You now say, well, I want to sleep, but the sleep will soon, the man will soon end the class. Therefore, let me just hold the sleep till 3:16. But if you get to 3:16 and I don't end the class, I don't want to use a bad word. You just say, and sleep up. It's your right. I didn't say anything, no. Now, example number what? 14. Organize the data below using an ungrouped frequency table. Is it an ungrouped frequency table? So I'm going to give you this data, 11, 10, 12, 14, 15, 21, 26, 1, 2, 3, 4, 5, 6, 7. 15, 27, 32, 33. No, let me not make it too large. Let me put here 14 again, 15, 17, 16, 25. Even 20 is too large for me. Let me put here 14, 17, 12, 10, 10, 18, 19, 19, 12, 16. That's how many? 1, 2, 3, 4, 5, 6, 7. 7 by 5 is 35, right? Okay, let me put one, okay, 14, 12, 10, 11, 11, 12, 13. Now, the reason why I was erasing those values, let's organize this data now using frequency, an ungrouped frequency table. To use an ungrouped frequency table in this instance would just simply mean if you take it up to 30, the longer the table will be. So what I'm going to do here will just be to put an ungrouped frequency table is a table of this nature. It has what? 2 columns. One column is for what? Your X column. What did we say the X column is called? Your data entry column. Is it not so? Data entry column. Then this one is for what? Frequency. Is it not so? And we call this one Fi. Fi. So I can use small xi or capital Xi, whichever one. Now here, I'm going to, how many values do we have? 10, 11, 12, 13, 14, 15, 16, 17, 18, and what? 19. Now, you will notice that if I had let these values run up to 30, the table will be very long. You see it? That was the reason why I was removing those 20. Now, please look at it. How many 11s do you have there? How many 11s? 3. How many 12s? How many 11s? Sorry. Okay, we have 3 11s, right? How many 10s? 4 tens. How many 12s? Huh? How many 12s? Is what? How many 13s? 1. How many 14s? You see this 1. You see this, wait. You see this 1, 2, 3. So, how many 14s? How many 15s? Calm down. How many 15? How many 16? 2. How many 17s? How many 18s? How many 19s? 2. Now, just wait a minute. So, we are going to put here tallies. Tallies are bundles. Tallies are bundles of what? Of 5s used for counting data entries by frequencies or into class intervals. The first 4 strokes are crossed by a 5th horizontal stroke to make a bundle of 5. So my class ends here with this summary now. So for all, now please look up everybody. This is where we are going to round up. So I'm saying tallies are bundles of 5 strokes used for counting data entries by frequency. The essence of using tallies is to avoid that thing you guys were doing. 4, 3, no, 2, 1. That's the essence of using tallies. Now, another essence of using tallies is that you may be distracted while counting and you may miss counting because of that. However, the best thing to do is to put what? Tallies. Now, this is what I'm going to do. I'm going to start horizontally or vertically. 11, I will put a stroke here, 1. Okay? 10, I'll put 1 stroke. 12, 1 stroke. 14, 1 stroke. 15, 1 stroke. 14 again, the second stroke. You see it? Please make your strokes horizontal so that you don't end up confusing 2 strokes for 11. 17, 1 stroke. 15, that should be the second stroke, right? 17, 14, 15, third. 17, 16, 12, 10 and 10, 18, then 19, right? 12, 16, second stroke, 14, 12, 10, 11, 11. Yeah, you're correct. 12. Now look at 12. This should be the 5th stroke. To make 1 bundle, you now cross. Do you see it? That means you now have 5 there. Then 13 is what? 1. Now look up. This will just make everything clear. You now summarize 4 strokes, 3, 5, 1, 4, 3, 2, 3, 1, and 2. Thank you very much.